Welcome to Fantastic Vision. Please subscribe us before you watch today's video. If you always watch our channel, you may know the news that Chinese latest chip technology. Under the chip rules of the United States, EUV lithography machines cannot be obtained in China, resulting in the advanced mass production process being stuck on 14 nanometers. The reason is that processes below 7 nanometers require the use of extreme ultraviolet lithography technology to realize transistors' high-precision size reduction. This technology is dominated by Europe and the United States, and the manufacture of extreme ultraviolet light source equipment is complex. So they have always adopted a high degree of monopoly and blockade against China. Under the existing domestic nodes, only the realization of CFET transistor technology can achieve high performance. Manufacturing of chips. The Fudan University team took the initiative to undertake this important task, successfully introduced the new two-dimensional atomic crystal into the traditional silicon-based chip manufacturing, and successfully achieved a breakthrough in CFET transistor technology, which will effectively help domestic chips get rid of the EUV process. The development of the chip industry encounters a bottleneck. With the comprehensive popularization of the digital society, the importance of chips has become more and more prominent. What kind of chips can be obtained directly determines the upper limit of a country's technological development. This is why the chip industry has become the focus of attention in recent years. With continuous upgrading, only by completing the self-management of chips in China can the problem be completely solved. The reason why TSMC can become the top chip manufacturer is mainly due to the EUV lithography machine provided by ASML, and TSMC's instant technical feedback has also continuously helped to improve and upgrade the lithography machine. Although the advanced process can be solved in a short time, the performance requirements are met, but as the limit of Moore's law approaches, it also leaves a lot of problems that need to be solved urgently. With the improvement of the chip technology, the cost of the core making process has also doubled. The design cost of the 3 nanometers chip has reached $581.1 million, which has increased by more than 10 times compared with the 28 nanometers chip of $42.8 million. However, the more advanced compared with the previous generation of technology, the performance improvement is more limited, and even Apple has to consider the issue of output ratio. TSMC is also facing a similar problem. The price of a single wafer is also rising continuously. The 28 nanometers wafer is only $3,000, while the 3 nanometers wafer has broken through to $20,000. It was rejected, and the 3 nanometers production capacity was rejected by Apple, Intel, and other manufacturers precisely because of cost issues. Therefore, the market urgently needs new technologies to reduce costs. At present, chip stacking, chip technology, and other technologies on the market are the solutions that major chip manufacturers have come up with. Using the subsequent packaging process to achieve performance improvement, so that chips with different architectures can be packaged together without changing. In the case of the original process technology, the performance has been greatly improved. Although the problem has been solved to a certain extent, it is not a perfect solution. China, which has always hoped to overtake on a curve, has begun to make efforts, but the existing technology nodes lack the key equipment EUV lithography machine, and it is difficult to achieve chip manufacturing below 7 nanometers. Therefore, the chip can only be improved through new processes. Performance. To make up for the lack of process technology, I did not expect this shortcut method really succeeded by Fudan University. Fudan University conquers key technologies. Fudan University chose to start with chip design and develop the three-dimensional stacked complementary transistor (CFET) technology that can greatly increase the density. The silicon-based two-dimensional heterogeneous integrated stacked transistor technology was proposed and introduced into the traditional silicon-based chip manufacturing. 4-inch large-scale, three-dimensional heterogeneous integrated complementary field effect transistors was successfully prepared, and the integration density was doubled on the same node, which directly reflected the superior device performance. Compared with silicon-based materials, the improvement of the atomic layer precision of two-dimensional atomic crystals makes its ability to control short channels in small-scale environments more superior. On silicon substrates prepared according to normal procedures, three-dimensional stacked 2-molybdenum sulfide (MOS2) forms a heterogeneous CFET structure through a series of reactions. The low-temperature process of molybdenum disulfide is highly compatible with it, which can effectively reduce the difficulty of the process while avoiding device degradation. Once this technology is fully applied, it will effectively reduce the density of transistors. The CFET transistor technology has been listed as the focus of future development and is considered to be the successor of the GAFET process for 2 nanometers and 3 nanometers chip manufacturing. If it can be combined with chip technology, it can effectively solve the cost of chip manufacturing. At present, Intel has begun to expand the corresponding layout. The most important thing is to be able to reduce the dependence on advanced technology. As long as the performance can meet the standard, it is likely that the EUV lithography machine will no longer be needed in the future. After all, an EUV lithography machine with hundreds of millions of dollars is not just what you want. Yes, getting rid of the dependence on ASML is what is urgently needed at present. If the full application of CFET transistor technology can be realized, as long as the domestic 28 nanometers process can be self-managed, it will be sufficient to meet all the needs at the current stage. At present, the domestic chip back-end technology is still at the world-class level, which is also our corner overtaking. What do you think of today's video? Thank you for your watching.